Hi, everyone. Thanks for joining me today with the second section in chapter 13. This is actually the extension section, so it's adding on a little bit to section 2. Today, we're going to be talking about how to factor expressions. So, for our learning target, I can describe how to factor linear expressions. Now, when you think of the word factor, hopefully you think of um, something like we talked about making factor trees. We talked about prime factorization. When you think of factors, you should be thinking about numbers that multiply to get to a certain number. For example, if I were to say the factors of, let's go 12. Well, you're looking for the numbers that multiply to 12. So, like 1 times 12, 2 times 6, 3 times 4, so on and so forth, right? We talked about the greatest common factor. So if we had two numbers like factors of 6 and 12, 1 times 6 and 2 times 3, what's the greatest common factor that these two numbers have? Well, 6. Okay. So hopefully your mind takes you to something along those lines when we're talking about factors. Now, how does that relate to today? Well, for our vocab, it says when factoring an expression, you can write the expression as a product of factors. You can use the distributive property to factor expressions. Now, remember when we talked about the distributive property, we talked about there's usually an instance where we have like a number outside of parentheses. So something like x plus, let's just say 3. And we wanted to distribute this 2 into everything inside the parentheses. That means we needed to multiply the 2 times everything in the parentheses. In other words, it's just this expression, x plus 3, 2 times. Because if you remember, multiplication is just repeated addition. So 2 times x is 2x plus 2 times 3 is 6. And we would say we distributed the 2 to everything inside the parentheses. Now, you would get the same thing if you took this expression, x plus 3, and added it to itself. Because now we have x plus 3 2 times. Well, what's 3 plus 3? 6. What's x plus x? 2x. So notice that we get the same thing because multiplication is just repeated addition. Now, how does that relate to factoring an expression? Well, it's essentially taking an expression and taking out whatever they have in common, or it's like doing the opposite of the distributive property. Okay, so when we use the distributive property, what we're actually doing is we are expanding. Okay. Now the opposite of that is factoring. We can also go the other way. So we can factor and it kind of goes the opposite way. Notice how my arrow goes the opposite way. It's like the opposite of the distributive property. So let's see how we can do that with example 1. It wants us, for example 1, to factor out the greatest common factor. Okay, well, first off, what is the greatest common factor between 24 and 18? Because it says 24x minus 18. So let's find the GCF of 24 and 18. What are the factors that they have in common? Well, 1 times 24, 2 times 12, 3 times 8, 4 times 6. Those are the factors of 24. It's got a lot of factors. Factors of 18, 1 times 18, 2 times 9 gives me 18, 3 times 6, and that's all. So what is the factor that they have? What's the greatest common factor? Well, it looks like 6 is the greatest number that they have in common. So what that means that I'm going to do is I'm going to take this expression, 24x minus 18, and I'm going to factor out 6, right? I'm going to take 6 out of both of these. In other words, I'm going to divide both of those terms by 6. So let's do that. If I'm going to take 6 out, I'm going to write my 6 on the outside of my parentheses. Notice how it kind of looks like the opposite of distributing. So then all I have to do is divide my first term by 6 and divide my second term by 6. So 24x divided by 6, well, 24 divided by 6 would give me 4. So 4x, if you took 24x and divided by 6, you get 4x. Minus, we're subtracting, what's 18 divided by 6? Well, that would give you 3. Okay, I'm just going to erase this second parentheses and bring it in a little bit closer so it looks a little bit neater. And there you have it. We've factored it. If you wanted to double check your work to see if you've done it correctly, you could distribute your 6. What's 6 times 4x? 24x. And what's 6 times 3? 18. Okay, so we just divided each one of these terms by the greatest common factor. All right, that's how you do those types of problems. Let's see another example where you factor out a fraction. Okay, so we have, it says factor 1/2 out of 1/2 x plus 3/2. So here's our expression, and we need to factor 1/2 out of this. Okay, so in other words, we're dividing each term by a half. So I'm going to factor out 1/2, so that's going to go on the outside of my parentheses. And what's 1/2 x divided by 1/2? Well, anything divided by itself is 1, so I would just be left with 1x plus, and then what's 3/2 divided by a half? Okay, so 3/2 is a half times what? Well, that would be 3. Okay, if you took 3 and you multiplied it by a half, you'd get 3/2. Now, if you can't do that little mental math in your head, that's okay. Just take 3/2 and divide it by 1/2. And then follow our rules for dividing fractions, which is multiply by the reciprocal. So keep, flip, flop. And then these would, reduce to 1, and you'd be left with 3/1, which is 3, which is the same thing I got there. Double check. What's a half times x? 1/2 x. What's a half times 3? 3/2. So yeah, that is correct. Again, when you factor out this half, it's like saying you're dividing each one of these terms by a half. And lastly, for example number 3, it's kind of the same, but now we're going to factor out a negative number. So the question says factor out -2 out of -4p plus 10. So if I'm going to factor -2 out, I'm going to put -2 on the outside of my parentheses. And then I'm just going to divide each term by -2. So what's -4p divided by -2? Well, -4 divided by -2 is a +2. I'll just bring that p along for the ride. And then I've got 10 divided by -2. 10 divided by -2 would be -5. Okay, so anytime you want to factor out a negative, you can do that as well. Just divide each one of these terms by -2. All right, so there are 3 quick examples on how to factor out a couple different things from a linear expression. Hopefully that makes sense to you. This one is short and sweet. Make sure you get some practice in. Practice makes perfect. It's how you get better at anything in life. And let me know if you have more questions. I'll be glad to help. Thanks for checking this out. I'll see you guys later.